So hello everyone, I'm Chantal. So my project involves investigating the performance of aligned discontinuous fiber reinforced composites using the scaled up hyperdiff technology. But today I'm going to talk to you about a small part of my research which looked at mitigating an issue that occurs during tensile testing of these specimens. So the problem is during tensile testing, the ADFRC specimens are prone to premature specimen failure, and this is because of the high stress concentration that occurs around the gripping region because of the localized stress transfers from the gripping area to the rest of the specimen. So as a result, the failure strain that is achieved is not really a reliable representation. So you can see two different specimen configurations were tested, and both of them failed around the end tabs. The results were also compared with unidirectional continuous composites of similar constituent materials and shown to be much lower. So previous research that has been done here at the University of Bristol has shown that it is possible to suppress the premature specimen failure by using thin ply interlaminated hybrid specimens. So in this design, so the high strain glass material is used on the outside to protect the inner carbon layer, and this helps to minimize the stress concentration in the gripping regions. So the damage mode map here is shown, which tells you the 4 different failure modes that is possible for these specimens. So in order to be able to detect the failure of the inner carbon ply, so the specimen needs to be designed in such a way to achieve the failure mode of carbon failure and catastrophic delamination. So in this region, the failure of the carbon will show as a sharp low drop in the stress and strain curve, so it'll be easy to detect, especially with the glass material on the outside, so you can kind of see through the specimen and see where the carbon fails. So the damage mode map was created, so using the failure stiffness and strength of the non-hybrid specimens and the carbon and glass. And this was obtained by doing some tensile testing on those specimens. And so you can see here that obviously to get the specimen design to fail in the desired failure region, the absolute thickness and the thickness ratio of the carbon and glass material needs to be varied carefully. So consequently, the design configuration that was chosen was 10 layers of the ADFRC carbon sandwiched between 2 layers of glass material. So these are the results of the tensile test, and it confirms what was predicted, that the specimen design that was chosen failed in the desired failure region. You can see the sharp low drop where the carbon layer has failed. And as the test continues, the glass starts to delaminate as it carries the load from the testing. That's confirmed in the images on that side. You can see the black line in this in the gauge section of the specimen, which denotes like the single fracture of the carbon layer, and then the change of color of the specimen from black to white indicates that the glass layers are starting to delaminate. So also comparing those results with the non-hybrid specimen, you can see there's a significant increase in the failure strain. So to conclude, it is possible to identify the failure strain of the carbon layer by using interlaminated hybrid specimens. And the hybrid specimen compared with the non-hybrid had an increase in the failure strain by up to about 35%. So in future, I want to apply this same methodology to other specimen configurations, such as the UD continuous prepreg and also ADFRC composites that I will produce with 6mm fibers. If you want to know more about hyperdiff and the work that I'm doing, please come and find me at my poster. Thank you. And also thank you to Solvay for sponsoring this project. Thanks.